All right, welcome. In this video, we're going to talk through some energy diagrams. So the first question is we're looking at a chemical reaction, A plus B makes C plus D. And if we look at some things that we know from the problem, it tells us this reaction is endothermic. And if a reaction is endothermic, we know it's going to have this general shape. So the energy is going to end up higher than where it started. And the heat of reaction is 150 kilojoules. Let's start filling this in. So we've got our starting energy of our reactants, and we know that the energy is going to go up some and it's going to go down some. This right over here is the reactant, so that's A and B. This over here is the products, that's C and D. And the reaction's endothermic, so notice how the products are higher in energy than the reactants. That's because it took energy in. So endothermic means there's like an increase in energy. And then the heat of reaction, we use the symbol delta H for heat of reaction. The triangle, we say that as delta, and that represents the change. So it's the change going from the reactants to the products. So imagine I were to kind of draw an extended kind of dotted line out here. The delta H would show us the change going from reactants to products. And then in this case, the change is positive 150. So that means that the products end up with 150 kilojoules more energy than they started with. The activation energy is this initial amount it goes up by. The symbol for activation energy, we sometimes use this symbol, E with a subscript A. And so the activation energy is positive 300 kilojoules. And then the activation energy corresponds to the energy needed to break bonds. Okay, so this area right here is the energy to break the bonds. And then over here, this is the energy released when forming new bonds. Okay. And then right here in the middle, this is what we call the transition state. So it's in between when bonds have been broken, but no new bonds have yet been formed. That's that area there in pink. All right, so now let's look at another one. At this reaction, we've got a molecule of, this looks like ethanol, reacts with 3 molecules of oxygen gas to produce 2 molecules of carbon dioxide and 3 water molecules. So first, let's just write this out. So I've got C2H5OH. It is a liquid, so I'm going to label that with an L for liquid. And 3 molecules of oxygen gas, so I'm going to use G for gas, is going to produce 2 molecules of carbon dioxide, which is a gas, and then also 3 water molecules. And water, we'll assume, will be a liquid at room temperature. All right. And what type of reaction is this? Well, it is something reacting with oxygen, so that is a combustion reaction. Whenever you have something reacting with oxygen and it forms carbon dioxide and water, that is a combustion reaction. So now let's map out the energy for this. Okay, so this question says, what is the heat of reaction for this chemical equation? And it might help to draw a graph to help us figure this out. So that's what I'm going to do. I'm going to use down here this graph for part D. I'm going to use this to answer question C as well. All right, so it looks like the energy released when products formed is, let's see if we can fill this in. So here's well, actually, let's look at this. Okay, so the activation energy, I'm going to write it down this way. The activation energy is 4,730. So that is the amount of energy going in initially. And then the energy released from the, forming bonds is 5,750. So that's the amount it goes down by. So if I'm going to sketch this out, here's where my reactants start. And it looks like it's going to go up by 4,730 kilojoules. That's my activation energy. That's the amount that my graph is going to go up by. And then it's going to release 5,750 kilojoules of energy. So these are my reactants. These are my products. And it looks like in this reaction, I released more energy than I took in. Okay, so I only took in about 4,000 kilojoules of energy. I released 5,000 kilojoules of energy. So question C is asking, what is the difference here? So if I were to kind of extend this line out, what is the difference here between the reactants and the products? And if I look at the difference, I go up by 4,730. I go down by 5,750. So the difference is, I'm just going to subtract those two numbers. So I'm going to bust out my calculator. So 4,730 minus 5,750, I get negative 1,020. So, excuse me. So with this reaction, what we're seeing here, this reaction is exothermic, and overall it is going to, release 1,020 kilojoules of energy. So that's why the delta H, we'll find that for exothermic reactions, delta H is negative. That's because it's giving off energy, so you end up with less energy than you started with. Okay. Yeah, and then let's go and label these things. So let's label the activation energy, which is the energy needed to break bonds. So that's this area right here, boom. And then the energy released when new bonds are formed is this area right there. And then this right here in the middle is the transition state. So that's when the bonds have been broken, but we have not formed any new bonds yet. All right, thanks for watching.